Okay, so we have a few different tricks that we are going to learn about today. Okay, so let's talk about what we just discovered. So we're going to go kind of out of order. We're going to come down here to theorem 1015. Okay, if we have angles inside of our circle, because we have two chords inside of our circle, it is important that we're talking about how these are chords. Okay, if we have two chords intersecting, creating angles, then we know that to get our angle measurement, we can take arc plus arc and then divide it by 2. Okay, and that's something that, okay, were we able to find those measures earlier? Yeah, with a lot of triangles and linear pairs and yada, yada, yada. Now we can just, okay, this is going to happen every time. We don't have to make those triangles. We can just, oh, hey, this is the rule. Okay. Okay, so JM has a measure of 130. And we're going to say KL has a measure of 156. Okay, so draw that picture. That's going to be the first example that we do. Okay, so in order to find the measure X, notice how we have two chords inside of our circle. We can take 130 plus 156 and divide it by 2. Get that for me? 143. What do you mean by this type of geometry? Triangles are pretty important. I think I made that. All of our sine, cosine, tangent stuff. This won't be like as prevalent as some of the other topics, the circle stuff, but this is more of a geometry specific topic. How do you think we should solve for y? Is 102 immediately helpful? No, we should probably look at, okay, so this is 78 degrees right here. Hey, 78 is going to be more helpful. So am I going to add 78 and 95 and divide by 2? No. 78 is the measure we get when we take y plus 95 and divide it by 2 or multiply by 1/2. Potato, potato. Okay, so 78 equals 1/2 times the sum of y plus 95. How do we solve this?
We divide 78 by 2.
Okay, we need to undo the 1/2 by multiplying both sides by 2. Okay, then we can subtract over that 95 to get 61. Did I do that right? Okay. It's warm in here. Yeah. But hey, it's been in the 70s today. Spring is coming. All right, so let's go back up to the top here. Okay, I don't find this to be like super earth-shattering because I don't think I would need to teach you this theorem and you not know how to do these problems. So we're talking about if we have a chord and a tangent, then we can take the intercepting arc and cut it in half for the measure. Well, yeah, because we have a vertex on the circle, right? Okay, we cut the intercepting arc in half. Okay, so let's look at what that would look like. Okay, I'm gonna have you draw this super awesome circle right here. With a tangent. Ooh, that was a bad tangent. That's a good tangent. That is a 220. Okay. What's true about 220 and 140? They add up to 360. Okay. So since arc AB is 140, angle 1 is created by, yes, a tangent in a chord, but the vertex is on the circle. So what is the measure of angle 1? 70 degrees, because all we have to do is take the arc and cut it in half, just like we did yesterday. Alexa, are you okay with that? Okay. Arc ACB is 220 degrees. That is the intercepting arc of chord AB and the tangent. So we can take 220, cut that in half to get angle 2 is 110 degrees. Also, angle 1 and angle 2 form a linear pair. So even without knowing the 220, we can get 110 because those two are a linear pair. It's like one of the first things we learned, and it comes back every chapter. Yep. 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 Or we know a full circle is 360. Okay. All right. Let's go ahead and go to the next page. This is where it gets a little interesting. Okay. Here we're going to talk about angles outside of the circle. So this can happen with two tangents, two secants, or a secant and a tangent. But notice how in each of these three pictures, we are looking at, I'm gonna kind of make it pink. This angle, this angle, this angle. And you'll notice how our process is very similar to our inside circles, but this time we are going to subtract. So we are going to take the two intercepting arcs, arc and arc, subtract them, divide by 2. Intercepting arc, subtract them, divide by 2. Intercepting arc, subtract them, divide by 2. So if we have angles inside of our circle, we take the two intercepting arcs, add them to divide by 2. If we have an angle outside, we're going to subtract the two intercepting arcs and divide by 2. So we'll draw a couple pictures so we can kind of get the idea here, okay? What I did is draw, what kind of line? I drew a tangent. Now I'm going to draw a secant. Okay, so we need to find the angle that's labeled as X. Since we are outside of the circle, we need to take intercepting arc minus intercepting arc and divide it by 2. So we're going to take 178 minus 76 and put that 1/2 out there. What would I give it? Okay.
Do you always just subtract the smaller angle from the big one?
Yes. Yes, because we don't want a negative angle.
So whichever one's bigger, you just subtract the smaller one.
Yep, good questions. So we get 51. Okay. Okay, this is the last picture you're going to have to draw yourself. Sound good? What kind of lines did I draw? 2 secants. We're going to solve for the measure A. All right, are we going to take 40 minus 30? No. What two numbers are we subtracting? Okay, we're taking A minus 40, cutting that in half to equal our angle that's on the outside, 30. Okay, so really we have 60 equals A minus 40. So A would be 100. Is that okay? So since it's A minus 40, we gotta add the 40 over to the 60.
Oh, I did like 60 minus 40.
Yes, you did. Okay, so let's go to the next page and let's look at a couple of things. Okay. What I want you to do is I want you to answer for me numbers 1, 2, and 3. Oh, look at me, I'm writing. Answer 1, 2, and 3.
Also, we had a geometry about circles.
So circumscribe is inside. Yeah, you will not have to worry about circles.
You had fell asleep through
I know. Like off the top of my head, not right now.
I was gonna go back.
1, 2, and 3.
so I didn't know how to do it.
I just took all the mandatory classes, so my senior year.
Okay, you have 1 minute. 1, 2, and 3. Go. All right, what's angle ABC? 110. Okay, what about arc AB? 140. What about AEB? 220. Good. Okay. All right, the one that I want to look at here before we end our time together is number 9. I want to make sure that we can get this set up right, and I want you to be careful when you have subtraction inside of your algebra. So do we have an inside or an outside circle? In number 9? And did I say circle?
Yeah.
I meant angle. Do we have an inside or outside angle? Now I understand why you said inside. We have an outside angle. Our outside angle is going to equal half of the difference. Okay. Which arc is going to come first in our subtraction? Okay. 4x plus 8. And we need to subtract 3x plus 2. But when we subtract a quantity that has more than one term, we need to make sure we subtract it in its entirety. So I need to put 3x minus 2 in parentheses because we have to subtract the whole thing. This is really 4x plus 8 minus 3x minus 2. That's really what that is. What? Because we're subtracting all of it. We're subtracting the 3x plus 2. So we're subtracting the 3x, we're subtracting the plus 2. Okay. Now what should we do? Okay, so I'm going to do 2 things at once. We can do that, right? So number 1, I'm going to double both sides to get rid of the 1/2. What? No, because the 2 goes to the 1/2 and they cancel out. right? Like this 2 times 1/2 is 1. And now we have 4x minus 3x and 8 minus 2. Just want you to be careful with your algebra, okay? So your homework is in your packet, pages 10 and 11, it looks like.
When you just add it up to 360,